Participants are required to please stay on the line and we'll get you soon.
Hello. Can
Yes,
you?
sir, you are audible. Yeah.
Begin.
So you can start the present conversation, sir.
Okay. Okay. Let me know once it is visible. The visible.
Yes, so the
Yes.
PPT is visible.
Okay. All right. Fine.
Sure. Yes.
Okay. Right.
So we can welcome address. Yeah.
Yeah. Okay. Go ahead.
Distinguished chief guest, branch counselor, team members, and participants. Good evening to one and all, owner of the dais. IEEE Student Branch brings out the hidden talents of students. It encourages students to be creative, innovative, and technically astound masterminds. Today, we've gathered here on this webinar session to nurture and enhance our knowledge about some real things that happen around us right everywhere. We are honored to welcome our chief guest, Mr. Ranjit Kumar M., Director of CCTI, JCI Vice President, Zone Trainer of JCI India. Sir has been through a great career in embedded systems, communication protocols, etc., and has gained expertise in PCB designing. He's also active and doing projects in his field of study. We are eagerly awaiting to listening to your keynote address, sir. We, with gratitude, welcome you to this webinar, sir. We take immense pleasure in welcoming our student branch counselor to this webinar. With Sir's guidance, we focus more on scientific research and work hardly to bring innovations. Sir has been supporting us through all possible manners. We cordially welcome you, sir. Our hearts brim with gratitude to welcome team members who have worked day and night to see the smooth conduct of this program. It's indeed a privilege to welcome the participants who wish to gain information through this informative webinar. Once again, I welcome you all to the webinar on IoT in healthcare conducted by IEEE GCT Student Branch. Sir, the dais is yours.
Thank you, actually, students chapter and GCT on behalf of Crystal Clear Technology and Innovations. Okay, so thank you. Uh, let the topic. Yeah. So today we are going to see about IoT in healthcare. Okay. So IoT is on a new technology to our society. It's already which is present in our day-to-day life. Yeah. So we are using a lot of devices nowadays. So mobile phones, a lot of smart devices. Of course, we are in the so we are all connected with devices, data, information, all that stuff. Yes. Okay. So so we are going to focus about this Internet of Things, where particularly applied in solution. We have a lot of inventories are there, especially in transport industries, healthcare applications, and of course, and defense side, security side. So all those sites are implementing this IoT, and we are moving up to the next stage also. That is another set of artificial intelligence. Okay. So right now we are going to see about what are the various inventions are there in healthcare setup, and what are the products are available, and what are the applications are used in the IoT healthcare. So these are the topics we are going to see today. Okay. So before going to the topic, we just clarify what are the various revelations on what are the various stages in the technology improvement. So all the stuffs we can see. So my first thing is here, various revelations are there. Okay, so this is a kind of old pretty information, but we need to know what are the various technologies are evolved or revelation are there. Okay, so especially in the industry 1.0, so that is called industry 1.0. So in the particular time period, there are some mechanic actually this particular industry 4.0, it is evolved in 1700 to 1800 periods. So the major concept here is a kind of a steam engine. Okay, the steam engine which is produce some heat. So with the usage of heat, we are going to do some automation process, kind of a new manufacturing set of process we are developed, like hand production, textile industry, mining industry, metallurgy industry. So using the steam engines of water, we are doing in the first revolution. Okay, so that is what the mechanization steam and water power. uh, so in the first revelation, we are facing some key challenges. So by day, we are updating with water into fuel, then fuel coming into the picture, then lot of CO2 emissions are going up there. So what going the next stage, it is a second revolution. Okay, so second revolution is a complete based upon the electrification production line. Okay, so the mass production and globalization engines, turbines, broad adoption of telegraph. So all those things are using the electricity way of things. Okay, so in the next stage we are updating the third revolution, and second revolution is around 1863 to 1947. It is a the major impact in the assembly line production. Okay, so in the second industrial revolution, we are majorly focusing on the assembly line production. And the next one, third revolution, okay, that is completely focusing on the electronics, IT systems, and automations. Especially, we are in the particular period, we are most majorly manufacture the PLCs, robots, and not a very intelligent robot. It's a kind of a very initial stage robots and automation, electronic controls, digital networks, digital machines. We are manufacturing the third revolution part. So it is around in 1970s to upon the 20th century. So it is a kind of 20th revolutions. In this period only, we are mostly we are going with microcontroller and PLCs, all those stuffs. Okay, so the next set of period is a fourth revolution system. It is a kind of what now we are speaking. We are in the stage only autonomous machine, like advanced robotics, like various digital cloud smart factories and machine learning, AI, cyber, physical systems. So all those stuffs are which is included the fourth. Okay, so these are the various revolutions in the industry. Okay, uh, let me. We are going furtherly with the fourth revelation only. Okay, let's deepen to the next slide. Okay, so Internet of Things. In short, I would say Internet of Things. It is a kind of a rapidly growing network of connected objects that are able to collect and exchange the data in real time using various sensors. And which is present in the car, refrigerators, and day-to-day applications, which are all say it is every anywhere and anybody we can connect. So we are sharing some informations with the usage of some devices. Okay, question is how is it possible? How this communication is established? What are the key basic technologies are used here? So these are the my questions are here. We cannot communicate simply. So there is some medium and we need to share the information based upon some protocols. Yes, we need to use some devices, all those stuffs are included here. Okay, so how it is possible, how this internet of things is established here? It is very very simple. In the third revelation we are found at some microcontrollers, right? So we are already having IoT and low voltage, high voltage applications are there, and we are found at uh, microcontroller, microprocessors and sensors. Okay, so that is a simply, I would say, embedded system. Okay, if I go here in the IoT architecture, this is a simple IoT architecture. Okay, so there are set of sensors are there. Okay, what is the usage here? So it is a collecting some information in the environment. Okay, so it is collecting some information from the environment. So the information which will be forwarded to the some microcontroller or some microprocessor. Okay, so then based upon the sensor input, we are going to give some output. So this is the basic kind of automation which is present in the third revolution period, approximately in the 1970s to 20th century. So let us assume this companies are there in the industry. So based upon the sensing element, we are controlling some conveyor or some other applications. Okay, so there is a some basic input and there is some controlling parts are there. So it is a basic set of automation. So in the IoT, we are collecting lot of informations from the sensors part. Okay, so by day, actually the sensor can able to send the signals in every second or every microsecond, I would say. Okay, so what we are doing, we are collecting this information from the sensor and which is receiving by the controller. Then we are transfer this entire data to the cloud for the future reference. Okay, why we need to collect this information? So there is some data we will analyze this parts in the future. Okay, so in that today we are receiving this much information. So okay, let us take into the tomorrow. Today we are having this much information. So then we will analyze, then we will having to the some common point. Okay, so the data is always in a powerful area. Okay. So this data which will be stored in the some cloud servers. Okay, so between the microcontroller and the cloud servers there will be some wireless communication medium. And before into the and the third revelation and the automation, there is no wireless communication which is present. Maybe in the very short distance we can communicate this information. Let us assume this motion will be present, which will be forwarded to the controller. And if I want to control some mission, then some onboard communications or some maximum 100-meter communication which be established in that factory. But if I want to store this much information in the cloud, then wireless communication coming into the picture, then we are sending this data into the cloud server. Okay, so in the cloud server we can monitoring and uh, there are two set of major application. One is monitoring and another one is controlling. So that is what our ultimate motto. If you look at some previous year projects or previous research, they are mainly focusing about two set of things. Only we are receiving some data. So what is the our motto? So we are going to monitor the things what happened there. Okay, otherwise based upon the monitoring inputs we are going to control that application. Okay, so this is our basic two things. Okay, we in the monitoring options we have a next stage mobile application development. Okay, so we can either monitor from the cloud server itself, or we can monitor in the some basic mobile applications. So there will be some connectivity into the cloud server into the mobile app. So this is a very basic IoT architecture. Okay, now we will focus upon what are the various sensor and what are the IoT gateway or IoT framework and what are the various cloud servers are present and who are the providers? I think this part mobile cam, who are we can develop, but cloud servers, controllers, and sensor, we have some common manufacturers are there. Okay, so there are some brands are there, or some common providers in industry are present. Okay, maybe we'll go to so these things I already explained. So there will be some input. Okay, so the inputs we are collecting from the sensors. Okay, this particular information which is forwarded to the machine or controller or computer. I would say these three things, it is the same. Okay, for your understanding, it may be in a machine or controller or computer. Okay, so based upon this inputs we are doing some output. This is a very basic embedded system. Okay, so we are controlling some machines based upon our inputs. So we will program into the this controller. Okay, so there will be a in the programming in it will be in the C or C++, whatever in the programming language. Okay, so we will program to this controller. Okay, listen controller, this is my input. Whenever you are getting this input, then you can trigger this some motor or some relay or some application. Okay, so this is what we are going to program into the controller. Okay, so this is basic ML system. The next set we will focus about the inputs. Okay, so these are the sensors. The in the IoT part, or otherwise I would say in the automation part, the major key role is in a sensor. Okay, because if you are receiving some error information, or if you are receiving some mismatch information, then our entire automation will get failure, or my entire system get react some other opposite way. Okay, so the sensor is a playing in some major roles. Okay, so yeah, so in industry, I would say the some other basic sensors: temperature, oximeter, accelerometer, IR, and radar, electrostatic, gas. So all of these things. So major sensors provide some low voltage. The very low voltage, I would say, it can provide in the millivolt itself. Okay, so maximum it can give 24 volt in terms of DC. Okay, so sensor, so it is giving some voltage information based upon the environment inputs. If I take some IF% then it will give some digital output. Okay, in the sensor itself there will be two set of sensors. One is analog sensor and digital sensor. These are the very traditional sensors, but in nowadays it is a communication protocol based sensor. If I take this STM IAS3DHHC, so this is a kind of sensor which can be senses to the pressure. Okay, it is a communication based sensor. In previously we are having three pins in each sensor, like power, ground, and there is some output pin. But today we have some common two pins. So we have to using some protocols. If you are following the protocols, we can transfer the information from the sensor to controller. Otherwise, you cannot do. So communication protocols, it is a very major role play in the sensor part. Why we need to communication protocols means in previously, I already told, if you are receiving some wrong information or mismatched information, some like collision information, then it will be an lead to issue, right? So if it is in a protocol based, then it is samples in the particular time period, and it is shared the information based upon the set of parameters, based upon the frequency, and it have some checklist also in the registers. Okay, if it is the like I would say very basic terms, if the time is greater than this, then there will be no communication, and it will check the errors also inside of the registers. Okay, so there is some communication protocols like UART, SPA, I2C. These are the basic protocols, but today we have some advanced protocols to LIN, like CAN, FlexRay. Okay, but I would say in most of the sensor are operated in the SPA or I2C based sensors. Okay, so this information which will be communicated in the bit coded information, then the bit coded information which will be received into the microcontroller. Okay, so based on the operations, they will so microcontroller it is a decision taking one. Okay, because whatever we are programming the controller, it will act like our instructions. Okay, so we will receive the inputs from our sensor, then we are processing into our microcontroller using some of the some features are where it is insidely present, so that is called peripherals. Okay, so we are receiving the information in the microcontroller, then we will moving into the output part. Okay, so in industry we have lot of product manufacturers for this microcontroller or microprocessor. I would say STM, and Admega, PIC microcontroller, ARM microcontroller or ARM microprocessor, Nauton, Renesas, Infineon, Texas ICs. So these are the major product manufacturers of microcontrollers. Okay, so if you are going to build a system or if you are doing some projects, always choose some advanced microcontroller. Otherwise, in nutshell, I would say it is based upon your requirement. If you have any, if you want to sense only blood pressure, or if you want to sense only ECG things, then your input is only one. Then you can go with some minimized microcontroller, and you have to check your efficiency and output, all those stuffs. Okay, yes. So the microcontroller selection part based upon your requirements only. Okay, so if you want to census in your body in like various of five informations, like what are the, like body position, EMG, glucose, or spiro sensors. So then your inputs are very high. Then you have to go with like this only. Okay, this is for when you are going to do some projects. Okay, select your microcontroller processor based upon your requirements. That's it, I would say, in a microcontroller part. And compare your and I will give you one hint additionally here, like uh, the project, when you're going to convert into the product, then select the feasibility of your microcontroller too, because in the initial stage you are doing some prototype part. So prototype means you can go with any controller and you are receiving your input sensor, then you are giving some prediction to your patient. Okay, so this is a very first time development, it is a kind of prototype. But if the project or your prototype convert into the product, then let us assume your product going to be used for 10,000 peoples, then you have to consider about your product cost also. So the product cost is majorly considering about your hardware part, because when you are doing your software, it is a one-time development. But microcontroller, if you want to update in your feature, then hardware it's a kind of issue. So before going to do your final product, just confirm your hardware is enough, or you need to consider your future purpose. So this hardware is enough for future, or is present is fine. So what is the cost it will be? Okay, let us assume STM microcontroller nowadays in around 800 rupees, but your watch in a normal if you are purchasing online some watch, it is around 1,000 rupees. If the microcontroller is 800, the watch is 1,000, means then it is not going to be a successful product. Your consumer doesn't want to purchase your product. Okay, so my if you are going with some innovation or product, then choose your microcontroller accordingly, and of course your sensors too. Okay, yeah. Then the next part is uh, so this is a general concept. we are controlling our inputs, and we will going to the do the decision making. This is a kind of basic things. Our code will be injected to the our controller, so the controller will act as whatever we are receiving the inputs. Okay, so I already told these are the various microcontrollers processor. So STM microchip is producing the PIC microcontroller, and this is some Nauton and Infin and Atmel. Okay, so these are the various microcontrollers and processors. In a medical sector, mostly it will be some efficiency oriented control and low voltage application control. Because if you are injecting some voltage, or if you are putting some device in your body, then it should be a very low voltage things, not a high voltage thing. I would say it is a very 3.3 volt DC oriented applications. Okay, so in the particular healthcare, we will going with the low voltage applications only, not on a high voltage purpose. Majorly, controller can work a 5 voltage DC, so we will go with a 3.3 voltage. So again, it is based upon your requirement, whether you are going to use in inside of the body or outside of the body, or it is only measuring purpose or tracking purpose. So all those things you have to decide when you are doing your requirement. Okay, so now coming to the and previously we are discussing very common things, like what are the common sensor, what are the common processors, and how this embedded system are actually doing. Okay, so now coming to the our uh, healthcare part. Okay, so in healthcare there are a lot of sensors are there. Okay, so airflow, GSR, ECG, lot of sensors there. So body position, so if I taking body position sensor, so this is used to monitor the various patients' positions, like whether it is standing, sitting, or supine, prone, left or right. So the body position can be able to sense using the sensor. So there will be a triple axis accelerometer which is present in this sensor. Okay, so this is the body position sensor. And ECG sensor, it is electrocardiography. It is collecting electrical signals generated by a heart. Okay, so this is the ECG. And EMG sensor means like it is electromyography sensor, I would say. So it is a medicine technique for evaluating the and recording the electrical activity produced by skeletal muscles. Okay, so these EMG signals are used in the many clinical and biomedical applications. Okay, and glucose sensors is used to measure the blood glucose concentration of a patient, and are an important part of managing diabetes and mellitus. Then snore sensor, it is used to neck and records vibrations. Okay, it will present in the neck, and it is measuring the actually it is listening to the air medium through microphone, which is located in the patient's neck or chest. Okay, so this is a kind of a piezoelectric sensor. Okay, so it is actually measuring the some vibrations in the various parts. Okay, and spirometer, it is an it is usually used to do a breathing test, whether your inhale and exhale is going properly. So it is majorly for asthma patients. Okay, so yeah, it is for a breathing or breath test it is used. And GSR sensor, it is a galvanic skin response sensor. Actually, it is measuring the electrical conductance of the skin, like whether it is a strong emotion, or it is identifying the nervous system, and it will result the uh, skin signals. Okay, so and airflow, yeah, it is a what are the flow of air medium in the various parts, and temperature, identify the body temperature, glucometer, blood pressure sensor. Okay, so these are the basic sensor, and I would here these all sensor are low voltage applications. Okay, so this is the point. The another thing is, if you want to communicate this sensor are will be provided the bit coded information. Okay, so the application may variant, but all the sensor will produce one will give a bit coded information. The bit coded information which is going to the microcontroller part. So then microcontroller receiving this information, and we will write some codes. If we are receiving this information, then we will transfer this to cloud or a mobile app, whatever. Okay, so these are the various sensor which is present for healthcare applications. Okay, the next part, okay, we are discussing sensors. Okay, in healthcare as well as in the normal say, and we are already discussing the microcontroller or microprocessor. Okay, then another thing is cloud. Okay, we will see one basic example here. So let us assume there is a patient. Okay, we will monitoring the heart rate, monitoring and blood pressure. Okay, there will be two sensors. The sensors which is transfer the data to actually it should be here one controller will be there because a sensor cannot be transferred direct to the cloud. Always there will be a microcontroller will be present. And one more interesting thing is a sensor inside of the sensor there will be a separate control is there. Okay, maybe here this is the very basic controller. Okay, it will receive the information, then it will give some output. But if I going here in the sensor part, it is sense the information and it will be stored in somewhere. So there is some ICs already which is present here. Okay, but in nowadays there is no such a feature like this information cannot be directly going to the cloud. Okay, so then there is a next medium we are required a microcontroller. The microcontroller only can able to transfer the data through IoT cloud. Microcontroller maybe in your college projects you are using Node MCU, I guess, or ESP. Okay, but in nowadays some advanced systems have inbuilt Wi-Fi connections, all those stuffs. Okay, if you are connecting your internet, then this data will be going to the IoT cloud part. Okay. Sorry, a little bit disruption. Uh, 1 second. Okay. Okay. Where I'm staying. So here. So the data will be going to the IoT cloud. Then the IoT cloud have some virtual space. Okay. It is not a really present hardware. It is a kind of a cloud computing technology. It is another technology. So cloud computing having some virtual space like a data storage. Okay, so what we are doing, we will send this information to the doctor as a report. Okay, parallelly if you want to use this data, we will do some analytic processing. Okay, so this information as well as monitoring by the some apps, it is used to for the diagnostics. Okay, so we can collect the information from the patient using some these kind of sensor or these wearable devices. Again, this wearable devices having some set of sensors because it cannot be directly sense information. So always there will be some sensor which is present in the every devices. So then if I take this wearable devices, so this is having some inbuilt ICs there. So this ICs will be going to the cloud. Okay, so this is the
Participants are requested to kindly wait for a few minutes. Participants are requested to wait here for a few minutes since Sir will be joining back after resolving the discrepancies with the internet connections.
Hello.
Yes, sir, you're audible right now, sir.
Okay. Yes. May I know where I stopped?
So can
Which
you
is
please
the?
present the PPT so that we
Yeah,
can
yeah,
see?
sure. What is the last slide we are discussing? Is the my screen is visible, right?
Yes, sir, we can.
Yes,
Yeah,
sir.
Uh, okay.
you can
What
go
is
ahead.
the
Here it
what
is.
is the market capital? Uh, uh, can I get some input? What is the last slide we are discussing?
So that flow chart.
This one.
Yes, sir.
Yes, sir.
Okay, fine, fine. Sorry. Then I'll go there. Slide. Okay, all right. Okay. So we are. Let us assume there is some patients. Okay. So we are receiving or we are measuring the patient heart rate and blood pressure using some two sensors. Okay. As well as we can connect some wearable devices also. So anyway, from these devices or these sensor, we are getting some data. Okay. The data which cannot be directly transferred into the IoT cloud. This much, this thing you have to confirm because the sensor cannot transfer data. If it is having some inbuilt communication feature or there, then it is able to transfer the data to IoT cloud. Otherwise, you have to put one other medium like one Wi-Fi module or Wi-Fi controller or a basic microcontroller you have to put here. Then you can transfer the data using some communication medium. Okay. In the wired protocol, yeah, it is using some UART SPI I2C. Okay. If I say heart rate sensor, it is a I2C based sensor. Okay. Blood pressure, it is a normal analog sensor. Okay. So this information which is going to the controller will receive the information through I2C protocol layer. Then this information which is transferred to the cloud using Wi-Fi module. Okay, so the controller selection based upon your requirement only. Again, I would say, okay, if you have only these two things, then you can select some basic things, basic controller like Node MCU, all those things for your project level. Okay, we are going with the product, then you have to update your microcontroller. That is a very important one. Okay, because if you are purchasing the Node MCU in the college, the project level, it is around 350 rupees. But if you are converting to the product, that it cannot work. Okay, then you have to optimize your sensor, all those things. Then only your product will be efficiently work. Okay, so the data will be finally going to the IoT cloud. The cloud is a kind of virtual space. Okay, so the data are stored in here. It is in the virtual platform, cloud computing technology. Okay, so using this data, we can analyze the information. What are the data we are receiving in the various parameters like time, or we say location, or we are receiving all this information from the sensor. Okay, yes. So the data which is used to the analytical, and parallelly we are sending some reports as well as a doctor, so which is used for the diagnostics, what we can do next, all those things. Okay, even patient can identify what are the dissimilar things present in your body. Okay, yes. uh, yeah, so in this flowchart, there's only one thing is missing, so there should be a one controller before going to the data to cloud. Okay, so now coming to this cloud part, what is meant by cloud is explicitly it is a kind of a virtual space, I would say. Okay, the cloud, it is a kind of another technology, cloud computing. Okay, the cloud, it is provided by this much parties: Cisco, ThingsWorks, IBM, Microsoft, ThingsPix, Azure Cloud. Okay, so these are the providers for cloud space. Okay, so initially they are giving some free space with a free of cost. If you are going with very high amount of data, then you need to pay this providers. Okay, so they are having different plans. If you are going visit this company sites, so they will have cloud purchase things. Okay, if you are maintain some hospital, then some companies will support for their patient monitoring system or hospital management system. Okay, so the cloud part included there also. Okay, I think most of the people are heard about this ThingsPick. It is provided by MathWorks. Okay, maybe some of the people are using Amazon Web Services and Google Cloud. If you are going with some companies, or if you're going with some organizations, then Cisco, SAP, PTC, ThingsWorks, it will be used there. Okay, so yes, again the thing is, if you are going with a product, then uh, select your cloud partner. Okay, I think we are discussing what are the things we are discussing: sensors and controllers and cloud part. A mobile app we can develop over based upon your requirements. But the major thing is we need to have sensors, okay, then controllers and cloud. So since any doubts? No doubts, we can continue. I need one response, please.
Sir, no doubts, sir. You may proceed, sir.
Okay, fine. So the next thing is market capital. The market capital, like how companies are focusing this sector, healthcare sector, using this IoT. Okay, so the IoT market day by day it is developing in the various sectors. Already it is a smart city implementation. We are having transportation, manufacturing, industry, and day-to-day home appliances, and uh, like city controls, all those stuffs. So similarly, we have some market capital in the healthcare part. It is Currently, it is around $90 billion. It is predicted in the 2026 $176 billion. Okay, right. Uh, yeah, we will go with the next mistake. We will discuss more. So what are the usage of this particular technology, IoT? We can go with the previous one, why we need to go this IoT. Yeah, there are some applications are there, lower expenses by monitoring the patients, because if a lot of patients are there, we need to um, some things we can measure using the sensors, so the expenses may be low and better treatment results. Because if let us assume one patient going hospital by day, improving their situation, instead of using this IoT devices, we can simply monitoring in the day home. Okay, so we can visit hospital by weekly or monthly, so the treatment results also we can see in the live. Okay, so as well as we can control that disease, like in the initial stage onwards, we can control our disease, like we can measure heart rates and blood pressure, all those stuffs. We can avoid this kind of disease control. Even we can avoid the fewer mistakes, and the minor medical errors will be there always, so we can avoid this fewer medical mistakes. And yeah, the medical storage systems, what are the storage available right now, so we can, what are the requirement now, so all the stuffs we can simply monitoring using this cloud. Let us assume in India we have a lot of locations, so assume here there are set of medicines which is available in a large number of quantity, in some other places in a less number of quantity, so we can simply managing in the single system, or we can supply and demand, we can manage here for the medicines part. Okay, yes, another one is a better decision control. In the COVID-19, yes, we are control the disease using prediction and day by day data only. Without that, it will be very like maybe it will continue 1 or 2 years, I would say. Um, Using this information data only, we can identify, okay, this particular area people are identifying a lot of cases. Okay, so we can put some barriers are there, so the disease can be controlled using this medical data only. Okay, so yeah, maintenance of medical devices, what are the, again, it's a storage part. Okay, so the supply and demand and disease control, treatment results, less expenses. So these much applications or advantages are present in the healthcare systems. Okay, so we will go by one, especially I have some 3 to 4 points to discuss in the healthcare sector. The first one is uh, like remote patient monitoring. Okay, so remote patient monitoring, okay, like first thing is we can identify the wearable things, wearable medical devices, like we can monitor our ECG, heart rate, temperature, all those stuffs using wearable devices. Okay, and in there is one particular application, this glucose monitoring. Okay, I think in 2018 in England, there is a company willing to support a remote diabetes treatment solution. Okay, so then this particular development has happened, glucose monitoring system. Okay, so it's a kind of a very simple devices which is monitoring the blood glucose level in the non-stop period. Okay, so this is a device. This information which is transferred to your Android or iOS device. Okay, the products are Freestyle Labor and Eversense. Okay, so actually it is developed in somewhere in 2015, but the product coming into the picture in 2018. Okay, so the this remote patient monitoring, we have some set of key challenges still now. Okay, so the first thing is I already told you this is a very low voltage application. We cannot give it the charger part very frequently. Maybe these are already digital systems. Okay, it is need some energy or some voltage frequently. Okay, if you are using continuous glucose monitor, we need to uh, recharge frequently. So this is a kind of one issue. Okay, uh, and it is a kind of a disruption to the particular patient. Without disruption of the patient, it should be measured. So these are the key challenges are present in the remote patient. But however, some hospitals are using the remote patient monitoring. This is not only for this glucose monitoring and tracking the wearable devices. I think in the COVID-19 we need to monitoring how many beds are available in each hospital. Okay, so that is a kind of a remote monitoring only, but not for a patient at the entire hospital. Okay, so here the devices are used, the information will be tracked to the cloud. Then we can monitor here. Okay, so this is remote patient monitoring, and next is deployment.
Your voice is not audible, sir. Participants are requested to wait here for a few minutes kindly.
Sorry, my network again get lost. Hello.
Yes, sir, you're audible right now, sir.
Okay, maybe I need to ensure from my side. Uh, So may I know where we are discussing the last part? Hello.
Sir, remote monitoring.
Okay, remote patient monitoring. Yes. So remote patient monitoring. Um, so here I mentioned only two things. For one is a wearable devices. Okay, the another one is a continuous glucose monitoring. Okay, the continuous glucose monitoring, which is from which is developed at in the 2018. Okay, so there is England Department of Healthcare and Social Care. They are willing to support remote diabetes for treatment the solution. Okay, so that time this is made this glucose monitoring. Okay, so actually what it is doing, the blood glucose level it will be measured. Okay, the measured data which will be transferred to the your Android or iOS devices. So these are the two devices: Freestyle Libre and Eversense. Okay, yeah, this is used for remote patient monitoring and your wearable devices. So in your, I think your watch is the best example. So your heart rate, blood pressure, and your walking distance, then your temperature, all those stuffs we can simply monitor in your watch. Similarly, the data can be transferred into the cloud. Okay, the next part is depression and mood monitoring. Okay, so this is very a crucial part. Right now, it is developed on the developing stage only, not it's developed. Okay, so so the depression and mood monitoring, it is a kind of a monitoring your how your whether you are happy or sad or you're normal or you're angry. So these kind of uh, mood we can monitor using your face things and your nervous system and your body inputs. Okay, in previous days we are I think this project is already in the develop kind of an implementer, but they are doing in the completely based upon your facial recognition. But in the healthcare side, it is measuring some inputs from the nervous system and how your nervous system and body it is reacted, what is the temperature, and all those stuffs are we are monitoring. So we cannot simply go with this solution because it is kind of lot of data are involved here. We can't predict this depression symptoms and other causes. But anyway, this is a kind of having a kind of a future is there. There are two set of studies for this think and halo neurosciences. Okay, so this think and halo neurosciences are already working on it. So and if this successful, then they made tremendous progress on this. Okay, so this is again in the development. The next part I would say here are tracked ingestible sensors. Okay, so this is very tiny sensor. Okay, so which is used to the doctor prescription uh, or how your medicines are working inside your body or the organism. So that can be we can sense from your inside of your body. So what we will do, we will sense some smart pills. Okay, the smart pills have some cameras. Okay, so the camera will capture the or visualizing your inside of your body environment of each organism. Okay, the smart pills are initially developed from the Proteus or it is a product from Proteus. So a lot of companies are working on the pill cam. Okay, yes, and yeah. So next one is mobile healthcare apps. Okay, so we are receiving a lot of information, right, using these sensors. Okay, there is another set of market for mobile application development. Okay, so they are producing day by day update and day by day work. So medication management apps, fitness, body activity, sleeping tracking, pregnancy, and health recording apps. Okay, so each setup there is some player. If you are taking fertility and pregnancy tracking, then there is some apps like Glow, Kindera. Okay, And if you are taking on-demand mental health, then there are some things, and medical marginal delivery, then pill tracking. So there is a one smart pill, if you are sending then pill, we can track it, and appointment and scheduling for the doctor discovery. Okay. So for fitness we have a lot of apps. So these are the mobile healthcare apps market. Okay. Till now, any doubts? Am I audible, right? Not lost.
Yes, sir, there are no doubts until right now, sir.
Okay, okay, all right. So there is next set of development are going there, like robotic surgery, connected contact lessons, and connected inhalers. So robotic sensor surgery, it is a kind of uh, the small, very crucial part. If you are doing surgery, then doctor maybe sometimes they will deviate in the platform. But if you are going with the robotic, it will crystal clear, it will doing. Okay. So already some laser treatment or some applications are already going, but a complete surgery with a robotic in the US, it is applicable right now there. I don't know in the India situation, but a robotic surgery, it is a next set of development. We will control these devices using from the one computer. Parallel, this information which will be uploaded in the cloud part. Okay. And connected contact lens. Okay, this contact lens is a next things, like it is used to collecting the healthcare data in a passive way. Okay, so there is some inside one micro camera there. Okay, so it will take a picture of your eye, all those things. Okay, so already contact lens which is available in the from Google. Okay, but not in the smart lens. Smart lens actually it is still under development. They are having some initial set of features only. Okay, in future we will have some uh, smart lenses. Okay, so there is some set of sensor which is detect your glucose level in your tears. Okay, so this is the use of connected contact lens and connected inhalers. So this is for especially asthma or COPD patients, like involving how asthma is attacking, and the which time it is attacked based upon the what parameter it is takes. Okay, so in the inhaler, there is one things. So if you are using in the what environment you are using, why this particular uh, um, attack is happening. So all the stuffs which will be transferred to the data. So which is useful to analyzing the what triggered an attack. So that is the use of the uh, unconnected inhaler. Okay. So yes, and yes, I already discussed the market capital is for 2026 is around $176 billion. So these are the companies are working on clinical efficiency, infant monitoring, sleep monitoring, fitness wearables, brain sensors, neurotechnology, consumer monitoring, and clinical grade biometric sensors. Okay, yeah. And the major issue is here the security part. Okay, we are receiving data for a patient. It is crucial information. So the data should be managed within the hospital or within the with the doctor only. So the data can be um, cracked or hacked by someone easily. Okay, so the IoT security concern, it is a very, very major one. So there is some regulations are present for this healthcare, that is HIPAA. This is a similar regulations. Okay, what happened actually, the 80%, 82% of healthcare organization report having experience attacks against the IoT devices. Okay, so then currently they are developing secure IoT hardwares and softwares. So one step addressing is this challenge. Okay, yeah, this is on working and the cyber security part. Okay, so right now, why most of the devices are not suitable? because of the insecurity. So your data can be tracked or can be cracked by anyone. Okay, so in the today applications, why we cannot get a lot of features means there is a regulation we need to follow. So all the softwares and hardware should be inside of the regulations only. Okay, so IoT security is playing another role. And key challenges in IoT. Okay, so some of the initiatives in still in the development only. Okay, and the lack of memory. We are having some very tiny chip. The tiny chip cannot have lot of memory. Okay, maybe if you're taking a sensor for a microseconds, it will send 10 data. If you're taking 1 second, then it will be 1,000 data. If you're taking one for a 1 day, it will be a very large quantity of data. So we cannot store all the data inside the chips. Okay, so we can store maximally some one MP sizes only. So we cannot doesn't have a very lot memory. So the low level of memory, we will lose some information in the device itself. Okay, so we will quickly transfer to the cloud, but if it doesn't have an internet connection, then it is another issue. Okay, then difficulties with regular updates. By day, we are having lot of hardware updates, software updates. Let us assume you are using some product from today. Okay, maybe it will update by tomorrow. Okay, then you need to give update in your software as well as. Correct, right? Am I audible?
Yes, sir.
Okay. So yeah, so you need to give regular updates in your software as well as hardware. And already told about the personal sensitive data security. Okay, the data security is another important parameter. And global healthcare regulations. We have a lot of regulations are there. We need to follow. So then only the product comes into the market. Otherwise, it will be hold there. Okay. Yes, especially in the COVID-19 part, we are applying this IoT for remote patient monitoring and healthcare management for electronic bed management system, and how vaccine are uh, induced are there. So vaccine cold chain monitoring and healthcare delivery drones. Okay, this is next another set of things. So in future, we will deliver the medicines using these drones only in the emergency purpose. Okay, so these are the various applications in the COVID-19 part. So in future, the wearable devices may continue and with the advanced features. So it is already in the top of the market. And surgical robots, it will be introduced in the future hospitals in a common reality way. Okay, and integration of other prominent technologies like the IoT. It is going to the next set of process. We have right now AI, AR, machine learning, big data, blockchain, and all the technology will be integrated in the current one. Okay, right now we have wearable watch. It is simply used to measure the heart rate. So if you are applying the machine learning, then it will predict your blood pressure for the next day. Right now we have a prediction for that, right? So based upon our current data or previous data, we will predict in the future. So the machine learning which will be do. So the big data handling, I already told there is a lot of memory issue. So this will be taken care from the big data. Okay. So these are the next set of trends on going in the IoT of healthcare. Okay. So if AI coming into the picture, then if you're taking the first one, health and social network, it is the first industry which will be going to the going up to 25% in the market for the next 10 years. Okay, so Yes, the job market of healthcare it is tremendously increased in the AI part. Okay, yeah, yeah. I conclude my session here. Any doubts?
That was a wonderful session which improved our knowledge on the topic, sir. There are
Yeah.
some questions related to the topic we
Mm-hmm.
received from the Google responses, sir.
Mm-hmm. Okay. Go ahead.
They are
What?
as follows. The first question is that is it possible to inject nanosensor into the body for early detection of cancer, sir?
Yeah, possible. That is under the development. Nanosensor are already developed. I already told about the smart pills. I think the smart pills is a kind of injecting camera inside the body. So nanosensor it is easily we can introduce in the body itself. That is possible. Based upon the sensor inputs, we can predict the what cancers. Yeah, it is possible. There is already sensors available in the market. Yeah.
Yes, sir. The next question is that in what
Mhm.
ways one can make a career out of IoT right from the basic level, sir?
If you are want to make a career in IoT, first you have to set your goal on which type of market you are going to work, whether it is automotive or again healthcare or again in a transportation or healthcare, sorry, home appliances or day-to-day application. Just set one industry, then develop your knowledge or skills in the microcontroller microprocessor. Okay, so you have to study some embedded systems. Then my very strong recommendation, study AI for the future market. Okay, there is a lot of trillion opportunities are present in the AI market, because in past 5 years if you are learning embedded system, that is enough for an industry, because that is the development there. But right now we have a AI market, and a lot of companies having their research on development fully on AI side only. So we have already a set of engineers with embedded systems or automation side. So the next set of is AI. So I would say learn AI and embedded. It will be a great future for your career. Yeah.
Okay, sir. The third question is that will the IoT in future might be increased or not, sir?
Definitely, it is already present now. It is already we are using day to day a lot of IoT devices only. Like wearable devices, it's a kind of IoT device. Yeah. Then I think in your smart home, a lot of devices are introduced there. I don't know, and smart city are there, smart transportation are there. So all are going through a digital way only. Okay. So this my question answer is it is already presented. Definitely, it will be go beyond on this. So again, I would say it is a kind of next update is AI only. AI in machine learning. Yeah.
Yes, sir. The final question from the Google form is that what are the challenges to combine the engineering and biology of a human using IoT, sir?
Challenges. Okay. um, like if you are taking a sensors input, then you have to take a right values and you have to predict the right diagnosis part. Okay. I think here I already mentioned various key challenges. We need to give regular updates, so you have to up to the trend. Okay, the first thing is, and you have to ensure your patient data and your hospital data. So data security is important. So this is another set of area that is kind of cyber security. It's another set of study, I would say. And yes, the major thing is you have to give a regular update. Like you have to set a right sensor, right controller, right product based upon your requirements, and it should be a very data secureable product. Okay, so this is the major key challenges right now in healthcare. Yeah, because we are already sensing lot of parts in our body. Okay, we are receiving lot of data already, but we cannot assure the data security right now. Okay, so as well as the first question, nano sensor. Okay, so the sensors also updated by day. So we will update our device by up to the trend. Okay, yes, is this
Thank you for your
answerable?
kind responses, sir.
Okay.
Now, I'd like to call upon the participants to post their doubts to sir by unmuting themselves or posting in the chat box, please.
Okay, I am receiving such questions. How does the short circuiting affect the sensor embedded inside the body? Okay, it is a kind of enclosed sensor. Okay, uh, enclosed sensor or enclosed devices. It couldn't affect the short circuiting effect. Can you elaborately explain Node MCU? Node MCU again is a kind of again a small microcontroller. Okay, so if you're doing a beginner projects, you can go with the Node MCU. So it is having some inbuilt Wi-Fi connections. I think in your college days you are using some Arduinos. I think Arduino or Node MCU, it is a similar thing. But my personal recommendation, don't go with some library codes, or don't go with for initial setup you can go with Node MCU. But for the next step, go with some advanced microcontrollers from especially STM and Texas or ARM. Okay, because these controllers are only used in the IoT devices. Will AI replace doctor in future? Your views on Elon Musk Neuralink? Yeah, definitely. Already in the last slide, I think I mentioned the manufacturing process. The machine is replaced now. So definitely in future, doctors may need it for the advice and monitoring only, not for the complete part. Okay. So A will replace the doctors, not fully, but partially will replace. What are the disadvantages in a neural link project by connected electrodes in the skull of the brain? Okay, then okay, that is the last question. Huh? Okay. Neuralink project. I don't hear about this project. Connecting the, I think I couldn't the right person for this answering this question. Yeah, maybe I'll answer you later. Shakti Priya. Yeah, yeah. Uh, okay. Maybe you can. Okay, one second. I'll present one. If you have any queries, kindly contact this number. We will explain the next set of studies and process. Okay. So we are Crystal Clear Technology and Innovation. We are present in Coimbatore, and we are providing service for the training projects, product and design internships for the various set of peoples like students, research professionals, and industry peoples. Okay. So if you have any doubts, kindly contact this number. We will answer your the questions for more. Yeah, we would like to hear from more. Yes, Shakti Priya, we will answer through your question shortly. Is there any other doubts? Uh,
I hope there are no more doubts. So let
okay.
me continue. It's my proud privilege to thank our chief guest, Mr. Ranjit Kumar M, for providing an informative session to us. We are grateful for having inculcating knowledge, sir. I take great pleasure in thanking our student branch counselor who has been supporting us constantly. His motivation and guidance keeps us on track. Thank you, sir. I feel proud to acknowledge the efforts of team members in organizing the webinar in a smooth manner. I thank the participants for participating and getting yourself clarified about the topic. Above all, I thank the Lord Almighty for giving us strength and the right atmosphere to carry on the webinar successfully. Thank you.
Okay, thank you, IEEE student chapter of GCT and students who are participating here. Okay, thank you. If you have any doubts, you can let me know this number. We will always